Imagine that there is a hidden source of energy deep inside our planet, waiting to be discovered. A source that could reveal the secrets of the most elusive and mysterious substance in the universe. Dark matter. Sounds like science fiction, right? But what if I told you that this is exactly what a team of astronomers has been searching for, using a giant detector buried under the ice of Antarctica? And what if I told you that they have found some intriguing hints of this phenomenon, which could change our understanding of the nature and origin of dark matter? In this video, we will explore this fascinating topic and learn how astronomers search for dark matter annihilation at the center of the Earth. One of the most amazing and mysterious things about our universe is that most of it is invisible to us. We can only see a tiny fraction of the matter that exists, and the rest is hidden in the dark. This hidden matter is called dark matter, and it is one of the biggest puzzles in modern physics. What is dark matter made of? How does it interact with ordinary matter? And why is it so hard to detect? Dark matter is a type of matter that does not emit or reflect any light, and therefore is invisible to our eyes and telescopes. However, we know that it exists because it has a gravitational effect on the visible matter around it. For example, dark matter helps to hold together galaxies and clusters of galaxies and affects the way light bends around them. Dark matter makes up about 85% of all the matter in the universe, but we have no idea what it is made of or how it interacts with ordinary matter. This is one of the biggest mysteries in modern physics, and solving it could have profound implications for our understanding of the cosmos. There are many theories and experiments that try to explain or detect dark matter, but so far none of them has been conclusive. One of the main approaches is to look for signs of dark matter particles colliding with each other or with ordinary matter particles and producing some observable signals. This is called indirect detection because we do not see the dark matter particles directly, but only their byproducts. There are different types of signals that could result from these collisions, such as gamma rays, X-rays, radio waves, or neutrinos. Neutrinos are especially interesting because they are very weakly interacting particles that can travel long distances without being absorbed or deflected by anything. This means that they can carry information from places that are otherwise inaccessible to us, such as the center of the sun, the core of a supernova, or even the center of the Earth. Yes, you heard me right. The center of the Earth. How can there be dark matter in the center of our planet? Well, it turns out that dark matter particles can be captured by the Earth's gravity as they pass through it. Over billions of years, some of these particles could accumulate in the center of the Earth, where they would be densely packed and have a higher chance of colliding with each other. If these collisions happen, they could produce neutrinos that would escape from the Earth and reach us on the surface. This is what astronomers have been looking for using a unique detector called IceCube. Isn't that amazing? Dark matter could be hiding right under our feet, and we could use neutrinos to reveal its secrets. But how does IceCube work, and what did it find? Let's find out in the next section. So, how do we detect these neutrinos? And how do we know that they are from dark matter and not from something else? Well, to answer these questions, we need to introduce a very special detector called IceCube. IceCube is a neutrino observatory located at the South Pole. It consists of more than 5,000 optical sensors embedded in a cubic kilometer of ice, about 1 to 2 kilometers below the surface. These sensors detect tiny flashes of light that are produced when neutrinos interact with ice molecules. By measuring the direction, energy, and timing of these flashes, IceCube can reconstruct the properties and origin of the neutrinos. IceCube is designed to detect neutrinos from various sources in the sky, such as exploding stars, black holes, or active galaxies. But it can also detect neutrinos from below, coming from the center of the Earth. You might be wondering, why did they build IceCube at the South Pole? Why not somewhere else? Well, there are several reasons for that. First of all, the South Pole has a very clear and stable ice layer that is ideal for detecting neutrinos. The ice is transparent and uniform, and it does not melt or crack easily. Second, the South Pole is very isolated and quiet, which means that there is very little interference or noise from other sources of light or radiation. Third, the South Pole is very convenient for detecting neutrinos from the center of the Earth, because it is exactly opposite to it. This means that neutrinos from the center of the Earth would travel straight through the planet and emerge at the South Pole, while neutrinos from other sources would have to travel through a longer and more curved path. But how can IceCube tell apart neutrinos from different sources? Well, one way is to look at their energy. Neutrinos from dark matter annihilation are expected to have very high energies, in the range of tens to hundreds of tera-electron-volts, TeV. This is much higher than most neutrinos from natural sources, such as cosmic rays or nuclear reactions in the Sun. Another way is to look at their direction. Neutrinos from dark matter annihilation should come from a small region around the center of the Earth, while neutrinos from other sources should come from all directions. By combining these two criteria, IceCube can filter out most of the background noise and focus on the potential signal. Isn't that amazing? IceCube is like a giant eye that can see through the Earth and into the dark. It can capture some of the most elusive and energetic particles in the universe and reveal their secrets. But what did IceCube find? Did it see any signs of dark matter annihilation? Let's find out in the next section. So what did IceCube find? Did it see any signs of dark matter annihilation? Or did it find nothing at all? Well, the answer is somewhere in between. IceCube found something, but it is not clear yet what it is. After analyzing 7 years of data from 2010 to 2017, IceCube reported that they found 6 neutrino events that match their criteria for dark matter annihilation. These events had energies between 30 and 200 TeV and came from within 5 degrees of the center of the Earth. This is a very rare and unusual occurrence, as IceCube expected to see only about 1 event like this in 7 years. This means that there could be something interesting going on in the center of the Earth, something that produces more neutrinos than expected. But before you get too excited, you should know that this result is not conclusive yet. There is still a possibility that these events are due to random fluctuations or unknown sources of background noise. In fact, IceCube estimated that there is a 13% chance that these events are just a coincidence. This means that they cannot claim a discovery, but only a hint of a possible signal. To be more confident, they would need to see more events like this in the future, or to reduce the uncertainty in their analysis. To put this result in perspective, we can compare it with other experiments and theoretical models. For example, another neutrino observatory called Super Kamiokande in Japan has also searched for neutrinos from dark matter annihilation in the Earth, but with lower energy and angular resolution than IceCube. Super Kamiokande did not find any evidence of such a signal and set an upper limit on the rate of dark matter annihilation that is compatible with IceCube's result. On the other hand, some theoretical models of dark matter predict that the rate of dark matter annihilation should be much higher than what IceCube or Super Kamiokande can detect, and therefore these models are ruled out by the data. However, there are still many other models that are consistent with the data, and that could explain the origin and nature of dark matter. Isn't that exciting? IceCube has found some intriguing hints of dark matter annihilation in the center of the Earth, but it is not sure yet what they mean. It could be a breakthrough discovery, or it could be a false alarm. It could be a new window to explore the dark side of the universe, or it could be a dead end. We need more data and analysis to confirm or reject this hypothesis. But whatever the outcome, we have learned something new and valuable about our planet and our universe. Thank you for watching this video. I hope you enjoyed it and learned something new. If you have any questions or comments, please feel free to leave them below. And if you liked this video, please give it a thumbs up and subscribe to our channel for more videos like this. See you next time.